All right, this is a sound check. How does this sound? All right. Hello, everybody. Welcome to 10606, Math Background for Machine Learning. This is the first mini. So hopefully all of you are logged on to our lecture stream and can see me now. As you probably heard from the email that I sent, this class is entirely online. So we're going to be streaming all of the lectures. We provide electronic ways to hand in assignments. We provide even online office hours, although you're also welcome to stop by in person if you like. So let's get started. The most important thing to know about the course to begin with is Canvas. So here's our Canvas site. You should all have access to it. I'm going to start just by briefly going over our course policies, and then we'll jump into the actual content. So bear with me for a second while we go through the boring stuff. So the course is split into two minis. Mini 1, Mini 2 are a sequence, so the first mini is a prerequisite for the second. Lectures are completely online. Even though we're an online-only class, you are expected to attend the lectures synchronously, meaning something close to real time. You know, a couple of minutes off of real time isn't going to be a problem, but not later the same day, not later the same week, not, you know, an hour before the final. And we won't be taking attendance, but we will sometimes have graded assignments that happen in class, like quizzes. Let's see, a couple of tricks. So YouTube supports playing video at 150% or 200% speed. So if you need to pause the live stream for a minute or two to go answer the door or something like that, you can play at 150% speed to try and catch up to real time. Yeah, and if you want to access office hours online, we're going to be doing them through Google Hangouts. And the contact information for us is online to do that. So let's see, I'm just going to go through our syllabus and point out any important points. So you guys all already know this link, otherwise you can't hear me. Our contact information is on Piazza. The best way to contact any of us is to post on Piazza. So the nice thing about Piazza is that whoever happens to be up at whatever hour of the night is going to be able to answer your question for you. If there's something private that you need to post, for example, if you need to ask about solutions to a homework, there's a private posting option on Piazza. Let's see, so there is a link to our live syllabus post. So the syllabus post on Piazza is going to be our class schedule. Let's see, I should be able to show it to you guys here. So here's our class schedule. And you know, today we're going to be talking about sets as soon as I get done with the introductory stuff. And there are lecture notes for each of the topics. I'm going to post them next to the topic name. And you can look at those. We're going to try and post them the night before at least. You can look at those before class if you want to. We'll go over them in class. Yeah, so I should say as well that this schedule is a prediction. We might go through some topics faster or slower than planned, and so we'll keep it up to date with the latest prediction so that you guys can, you know, plan ahead. And you can see as well that there's a recommended reading. So there are no required textbooks. You don't have to do the recommended reading. But what we're going to do is link you to recommended reading in the recommended textbooks whenever it's appropriate to do so that you can get an alternate presentation of the material. Let's see. I should point out Mini 1 last day of classes is October 16. There will be an in-class exam on that day. So again, in-class means just that it's due, you're supposed to be working on it during the class period. It'll be due a little bit after class to give you time to upload your solutions if you need to. And of course, there won't be a lecture during the exam. So last day of classes, an important day for the exam. All right, so here are the topics of the course. So we're going to start with sets and logic. The course is a little bit of an interesting beast in that we expect you to know at least something about at least most of these topics before you come in, because there's no way that we could cover, like, there are semester-long courses in each one of these things. There are many year sequences of courses in each of these topics. What we're going to do is basically provide reminders for people who need them, provide lecture notes and readings for people who need to catch up on these topics, and provide an opportunity to practice them. So this is not teaching very much material from scratch, or rather, we will teach it from scratch, but we will do so really quickly under the assumption that people will be familiar with a different subset, and if you happen to encounter a topic that you're less familiar with, then you spend a little bit more effort that week to catch up. And then hopefully the other weeks are easier. And so if you don't know all of these things, it might be impossible to keep up with the course. And then the goal is at the end of the course, what we'd like is for you to be, to have it all swapped back in, to be fluently solving problems in all of these areas, so that when you get to 10601 or 10701, those are our intro to machine learning courses, the math is just a breeze for you, and you're able to concentrate on the machine learning content. All right, here are the recommended textbooks. They're all really great books. Elements of Statistical Learning, the last one is available online if you search for it. So yeah, enjoy those. Hopefully you guys all know about the tools Canvas and Piazza and YouTube. Those are all pretty important for the course. We're going to be using Piazza as our primary discussion. So Canvas also provides discussion, but we'd prefer to have all the discussion in one place. So please put your discussion on Piazza. You can get to Piazza from Canvas, or you can go there directly. Yeah, so what do we, Piazza, my experience with it has been great. Like, students often answer questions within a minute of each other posting them. So if you want like a rapid answer to a question, that's a great way to do it. And then of course, the TAs and I will come along later and add to it anything that we think is important to add to it. Also, if you have questions during lecture, please post them on Piazza. I have it on good authority that all 4 of the TAs are watching Piazza right now. And so they'll answer your questions, and if a whole bunch of people have the same question, they'll send me a message and I'll try and talk about it in the stream online. Because it's synchronous, even though it's online only, course time conflicts are real conflicts. It would be possible to audit the course and miss, a good fraction of the lectures, but it's probably not possible to take the course if you're going to have to miss the lectures. Grading. All right, so probably best just to point out that this information is in the syllabus, but you'll be graded on participation, the final exam on the last day at the mini. There'll be in-class quizzes that count for 10% of your grades, short problem sets, 7 to 10 of those, that each one not that much work and not out for that long a time. Longer homework problem sets that are out for 1 to 2 weeks, and possibly extra credit. And we're going to do different from last time around. We're just going to do straight percentage grading. So if you want to pass the course, you need to get at least 2/3 of the information there. 2/3 of the answers correct. Hopefully you'll do much more than that, but that's the minimum. So let's see. We will look at requests to submit late work. Not on the quizzes. The quizzes have to be during class because we'll show the answers right after class. But for quizzes, if you have to miss one, you basically, instead of letting people submit late, we're letting people skip 2 quizzes that they pick. And so that is, that's in lieu of being able to submit them late. For all of the other ones, let us know. Usually there'll be a penalty for late work unless you have something like an illness or a religious observance that conflicts with it and that advanced planning wouldn't have allowed you to fix. You can audit this course or take it pass-fail. The requirements are lower. Basically, you'll be graded on just participation quizzes and the short problems, and you only have to get 2/3 of them right to pass. Regrades are possible. There's a limit of a week after you get the grade to submit a regrade so that we don't have a gazillion regrade requests on the last day of the course. We might have a shorter deadline for assignments near the end where we need the grades set so that we can submit final grades. Collaboration, we encourage collaboration in one sense, which is that it's great to form study groups. Since this is an online only course, it's it's not like you can ask people questions in the lecture hall after class. But let's see. What you should do is form these study groups, talk with people about general strategies for problem solving, and then once you're done with the study group, you take your notes, close them, put them away, and solve the problem on your own, right? And it's really important. People don't realize when they're working from a set of notes, that the solution process is going straight from the notes into the computer and not sticking in your brain. So close the notes and solve the problem, on your own when you're solving it, and submit your own work. If you do collaborate, you have to disclose these collaborations. Just drop a note to me or the TAs. If you need accommodation for disabilities, let us know. If you are getting stressed out at any point during the semester, please come talk with us. There are tons of resources that we can point you to. Always good advice to eat well, exercise, avoid excessive use of alcohol or drugs, and get enough sleep. I know that's hard advice to follow. I'm going to try and follow it myself. I know I don't always manage to get enough sleep. So if you experience any kind of stress, we're here to help. All right, we have one assignment that is live, and that is to log onto the Q&A, which is a web application that we're going to use for lecture notes and for questions. So the assignment should be incredibly easy. It should take you, less than 30 seconds. But we just like to make sure that everybody goes through and does that so that we don't run into troubles when we have a real assignment live. Please make sure to log in using your Andrew ID, because that's how we know who is logged in. So there's a big blue button that says something like login with CMU ID. Click that button. And that way we'll be able to associate your work on Q&A with your user account and give you credit for it. All right, so that's the syllabus. If you have any questions on the syllabus or on course policies or content or anything like that, please post on Piazza. If there are any questions on Piazza, in the next few minutes, the TAs will let me know to answer them in the stream. All right, so that's Canvas and Piazza. Let's switch now to the lecture notes. So if you've succeeded in logging onto Piazza, you should be able to have this link, to follow this link and get to the same page of lecture notes that I'm looking at here, and you can follow along. So I'm going to maximize this on that side so that we can see both the content and a whiteboard here. So I'm just going to go through this content now, and I will stop every so often, ask for questions, give you guys practice exercises to do. So let's get started. So the first thing we're going to talk about in this course are sets. Sets are basically just unordered collections of objects, no duplicates. The things in the set are called its elements, so you can write that as object in set like that. Object in set like that. So that's true if the object is a member of the set. And two sets are equal if and only if they contain the same members. One set is a subset of another if all of the members of the first set are also members of the second, and there might be additional members of the second. So some examples are integers written with this sort of funky looking Z, or real numbers with the funky looking R. That font is called Blackboard Bold in case you're curious. So 3 is an integer, pi is a real number, and the integers are a subset of the real numbers. Now, hopefully that all sounds familiar. Something that winds up being incredibly useful and that students are often less familiar with is called set builder notation. So set builder notation is a way to write down sets. So you can, the simplest way to write down a set is to list its elements, right? So you can have, you know, 1, 7, 13 is a set that we'll call S, for example. Or you can say that, you know, primary colors are red, green, and blue. But more interestingly, you can describe a set by giving a recipe for constructing its elements. So we have an example of that here. Even numbers are all 2x for every x in Z, right? And so the general form of a recipe is that you give an expression for the elements of the set like that, and then you list logical properties that the elements have to satisfy, right? So here, 2x is the element of the set, and the logical property is that x is an integer, right? So the integers, z is equal to, right, -3, -2, right? 2, 3, ... right? And I guess I should put a ... there as well, because they extend arbitrarily far forward and backward. And then we'll write e for the even numbers, right? And that's going to be twice each of these. So -3 goes to -6, -2 goes to -4, 2 goes to 4, 3 goes to 6, and so forth, right? So that's a simple example. And we can get a lot more complicated than that, and we will in this course. Let's see. So a nice shorthand is that sometimes we'll put one property inside this expression, right? So for example, the natural numbers, which we'll write n, that's equal to x such that x is an integer, and also x is bigger than or equal to 0, right? Sorry, this should be a z, that's not very clear. All right, and that's the same as saying x in z such that x is bigger than or equal to 0. And that's also the same as saying x bigger than or equal to 0 such that x is in z, right? And so both of these two guys are just shorthands for this one. We've taken one of the simple properties and moved it over to the left-hand side. All right. So set builder notation is useful enough that it actually appears in some programming languages. So the main programming language that we're going to be using in this course is Python. I should point out, by the way, that there's a really nice list of Python resources for people who are rusty on Python to refamiliarize themselves. There's a really nice post with a list of resources on Piazza, and we'll try and answer questions either here or in office hours or on Piazza for people who are getting back into the swing of things with Python, or for people who are teaching themselves Python from scratch, although again that's going to take you extra work if you need to do that. And so in Python you can write something like this: x squared for x in another set. So range of 4 is the set 0, 1, 2, 3. In general, range with an integer argument is the set of all integers from 0 up to the argument -1. So range of 4 is 0, 1, 2, 3. So x squared for x in range of 4 is the same as x squared for x in 0, 1, 2, 3, right? So in fact, often we'll even read the vertical bar as 4 when we write a mathematical set builder notation. And so this mathematical expression has a really direct translation into Python code. And so I encourage you guys, I'll pause for a second after I finish this sentence. I encourage you guys to go to this site called Replit. And so it's linked, but you can actually just type it, repl.it/languages/python3. That basically is an online Python IDE. It's a Python development environment that is just in your browser. It's a great service. They have some paid plans as well, but the free plan, if you have some little snippet of Python code that you need to execute, you paste it into their site on the browser and it executes it for it. And so here we have an interactive command line prompt right here and just an editor buffer there. So if I, for example, in the interactive prompt type x squared for x in 0, 1, 2, right, that should give me 0, 1, 4, right, which is 0 squared, 1 squared, and 2 squared. So I encourage you to play with that for a second. You can also put some code here, and it will execute every time you hit Alt-Enter or Command-Enter, depending on whether you're Windows or Mac. So we'll pause for a few minutes while people play with that. All right, so we're back from the pause. You guys are going to get an opportunity to play with that a little bit more shortly, because what I have here is an exercise for you. What I would like you to do is log on to Replit or any other Python that you have access to. So maybe you have it already installed on your computer and you do Python development regularly, or maybe you just prefer Replit. So what I'd like you to do is to write a function called notdiv that, given an input set S, whose elements are positive integers, gives you back another set that contains every element of S that is not divisible by 2, 3, or 5. For example, if you're given the input 1, 2, up through 7, it should return 1 and 7, right? Because 2 is divisible by 2, 3 is divisible by 3, 4 is divisible by 2, 5 is divisible by 5, 6 is divisible by both 2 and 3, and so 1 and 7 are the only remaining ones. And here's a reminder of the syntax for Python function definitions, and a reminder that mod, which is what you can use for a divisibility test, is a % in Python. So what I'm going to do is pause for a few minutes, give you guys a chance to implement that, and then I'll show you my own implementation and we'll go through it just to let you guys compare. let me say that again because I had my microphone off. You guys do not need to, this exercise that I just gave you, this is just for understanding. There's no need to submit it. We'll get to graded assignments later, but this is just for understanding, and in about a minute I'll show you guys the solution. See you in about a minute. All right, so, whoa, for some reason I'm out of focus. There we go. All right, so let's take a look at the the answer now. So I pasted it into a Python IDE. So here's the code. So here's the function definition: def not div of some numbers with a colon at the end of it. Python, if you recall, has a unusual convention that all blocks and all statement boundaries are indicated by white space. So indented a little bit is the return statement. That's the function body. So you return this set comprehension. And so the set comprehension is everything in the curly braces. It's x for x in our numbers if x mod 2 is different from 0, so that means if x is not divisible by 2, because if it's divisible by 2, then x mod 2 is 0. And x mod 3 is not 0, and x mod 5 is not 0, right? And so if I go and paste that definition into the interpreter, and I do the set 1 to 8, and do not, the set 1 to 7, right? I get 1 and 7. Let's do a bigger set just for, let's say, up to 18, right? And so hopefully all of these things should not be divisible by 2, 3, or 5. And in fact, they're all prime except for 1. And so they are not divisible by 2, 3, or 5. If we went higher up, we'd get some composite numbers, right? So if we did, let's say, up to 30, right? Some of these numbers should be composite. So there's something. Oh, right. Yeah, no, okay. So if we go, wow, a lot of these things really are divisible by small numbers. Let's go even higher. So hopefully, all right, well, so for example, 49 is 7 times 7, and so that gets filtered through even though it's not prime. All right, so that is that exercise. If you didn't understand that exercise, please post some questions on Piazza because it's only going to get more complicated from here. All right. So just to give you a little bit more practice, I'm going to do another exercise which is similar but just a little bit more complicated. So hopefully you should be able to, given the solution to the previous exercise, if you had trouble with it, you should be able to do fine on this one. So here, what we'd like to do is do set builder with a set of strings. So we're going to do the same sort of filtering on the set to find all of the elements of our set that are words that use only the letters A to M in lowercase or capital. So for example, given these words, you should return dig and eel because cat has a T in it, that's not A to M. Dog has an O in it, and O is not A to M, and ant has a T in it, which is not A to M, right? And in case you are unfamiliar with regular expressions, there is the regular expression to test whether you use only letters in A to M. If you want some practice on regular expressions, close your eyes over that part of the exercise and do what do what you can. So again, I'm going to pause the lecture for a few minutes to give you guys a chance to work out this exercise, and we'll come back in a few minutes with the solution. All right, so we're back now. Hopefully you guys have had a chance to take a look at the assignment and do it. If you haven't, now's your last chance to paste your code into the IDE. And here we go with the answer. So here I defined, so first I made sure to import the regular expressions package, import RE. And then I defined my function only a to m, which takes a set of strings as an argument, to return x for x in strings if it satisfies this predicate. And I gave you guys the predicate. And hopefully you would be able to modify it so that it was a slightly different predicate, for example. That might be an assignment that you could see on a test, for example. All right, so again, if this doesn't make sense to you, please post on Piazza. A couple of questions that people asked on Piazza. Python sets are with curly braces. Those are different from lists, which are with square brackets. But lists have actually a very similar comprehension syntax, and you can use lists for many of the same purposes as sets in Python. They have different runtime characteristics is the only difference, and lists allow multiple copies of the same member. All right, so let's go back to the lecture notes. So in addition to the operations that we've shown so far for sets. Some important operations include union, intersection, difference, and complement. So the union of two sets is everything that's in either set. The intersection is everything that's in both sets. It's actually a really nice thought exercise to be able to write out the set builder notation for the definition of intersection and union, right? So the intersection is x such that x is in big X and X is in big Y, right? That's the intersection, everything that's in both. X union Y is everything X such that X is in big X or X is in big Y, right? And so union and intersection are strongly related to logical and or. And you would be able to write Python expressions for them, maybe not the most efficient Python expressions, but just by very closely copying this mathematical set builder notation, you would get Python code. Set difference is everything that's in the second set, but not the first. Whoops, this is reversed. I apologize for that. I'll fix that after class. It should be, let me write out what it should be. So it should be x minus y. Oh, actually, no, that's correct. It's everything that's in the first set and that is not in the second set, right? So I apologize for getting confused. The notation is correct in the notes. And then finally, a lot of times we'll be working with a known universe of objects. For example, all 8-bit numbers or all students in 10606. And if we have the universe fixed ahead of time, the complement is the universe set minus the original set. So S bar, the complement, is universe set difference S. Right, and that's the definition here. So I'm not going to actually pause for this one, but whenever you feel like is a good time, it would be good to try and write down the expression, the Python version of this definition, right? Just follow the set builder notation and write yourself a function that does set complement. All right. So tuples and set products. So an important notion in a lot of contexts is a pair, an ordered pair. So that means if you have two objects, x and y, you can write x comma y with little angle brackets around it for for the ordered pair. I should point out these are not greater than and less than signs, and if you type them as greater than and less than signs, it will be very confusing to me and to other people who are used to the correct notation. If you are a LaTeX user, you can get them with /L angle and /R angle. You can Piazza actually lets you post equations using LaTeX notation. So if you post in Piazza $2 to enable LaTeX /L angle x comma y /R angle, right? With close the LaTeX with 2 more $signs, that will render as x comma y. Whoops, sorry, like that. And do not type a less than sign, x comma y greater than sign. All right, don't do that, please, because it will be hard for me and other people to read. All right, so ordered pair is just a data structure that says I'm passing these two things around together, and there'll be an operation that pulls out the first element and an operation that pulls out the second element. You can nest pairs to get a longer fixed length list of objects. So x, y, z, and w here is a nested set of pairs. Or you can define a tuple, which is basically a fixed length array or list, x, y, z, and w. And nested pairs and tuples can be identified by flattening the nested pairs, removing all the internal angle brackets. All right, so that's basically, if you're familiar with like a C record, a C record is basically just a data type of ordered pairs, or tuples if there's more than 2 elements. All right, so if we have 2 sets x and y, we can write the set product, x cross y, as the set of ordered pairs where the first element is in x and the second element is in y. Set product is associative, at least if you use flattening. So x cross y cross z is the same as x cross y cross z, and so a lot of times we'll just omit the parentheses. And so those are both the set of 3 tuples where the first element is from x, the second from y, and the third from z. And we often sometimes write x to the n to be n tuples where all the elements are from x. So here's a tuple of 5 integers. And again, they show up, tuples and set products show up pretty directly in programming. So for example, the argument list to a function is implicitly a tuple, right? So here, this is the standard argument list for a C or C++ function, void main of argc argv. And so this is a pair, an ordered pair, where the first element is an integer and the second element is a C-style array of strings. And so you could write that in a more mathematical notation as z cross string array. All right, so I will pause for a second to let you guys answer this question. You should just be able to click one of these radio buttons and click Submit Answer, and it should give you instant feedback. So we'll pause for a minute while you guys do that. It's an understanding check question about set product. All right, so we're back. Let's take a look here. The null set, the empty set, cross product with the set 1, 2, 3. The answer should be that it is the empty set. Whoa, I guess I need to reload Q&A for myself. The empty set, submit answer. Oh well, all right. I hope you guys didn't all get errors when you submitted, but the empty set is the correct answer, and I'll investigate why there was an error after class. Why is the empty set the correct answer? So the cross product between the sets x and y is the set of all tuples where the first element is from x and the second element is from y. There are no tuples whose first element is in x, right? Because there are no elements of x. And so the cross product between the empty set and 1, 2, 3 is empty again. All right, so hopefully that makes sense to people, and it's a good check of your understanding of set operations. All right. The last item in this set of lecture notes is another exercise. We're not going to do that exercise now, but I would like you guys to think about it after class, and we might assign it or something related to it in a homework exercise. So a database join. This is a concept that you might see in another class. It's a little bit more complicated of a concept, so this is sort of a more advanced example of how to use set builder notation. All right, so if you have a database, right, a database has multiple tables. Each table, you can think of it as a list of tuples, right? So for example, if you look at the student information database that you guys are all hopefully in to be registered for this class, it's going to have a table in it that has student information. So it'll have the student name, their expected year of graduation, the program that they're part of. Each one of those will be fields, and every record will have exactly the same set of fields. So that's a tuple, and the database, you can think of it as a set of tuples. It's actually a list, but in this particular case, we don't want the same student in the database more than once, so we can think of it as implementing a set. If you have two different tables, so for example, you could have all of the students who are registered for 10606, and you could have a table that had, for example, the semester, the name of the student, the professor's name, the grade that they get in the class, right? A different set of information. And so if you have these two different tables, two different sets of tuples, and if the two tuples have a field that matches, so for example, student ID is probably a part of both of those tables, then you can do a join on that field that matches. And what a join is, it says, okay, let's find all of the records that occur in the first table that have a particular student ID, and all of the records in the second table that have a particular student ID, and let's match those in all possible ways. Hopefully, there's only one row in each table, exactly one row in each table, that has a given student ID. I guess not every student in the university is registered for our course, so some student IDs will be missing from the second table. And so what you'll do is whenever you find such a pair of records, one in the first table, the other in the second table, you'll combine them together, and you'll take all of the fields from the first record, then the student ID, which is common between the two of them, you only include one copy of that, and then all of the fields from the second table. And the resulting set is called a join. Now, it can get a little bit more complicated because you could join on, let's say, the student's last name. Say that was a field in both databases. You might want to do that, for example, if for some reason the student ID got deleted from one of the tables, which would be a bad situation, but you could recover it with the power of database joins. And so what you would do is you would join on last name, and there might be several students named, say, Smith in the first table, and several students named Smith in the last table, and you would join those in all possible ways. And so if there were 2 in the first table that had Smith and 3 in the second table, there would be 6 possible records that came from that last name. And they would have all possible assortments of the way that you could join. So that's a database join. The set builder notation for database join is right here. And it would be interesting, it's a good exercise, to try and think about how you would implement that sort of set builder notation in Python to give a database join. Now, efficient algorithms for database join, this is not an efficient algorithm. Efficient algorithms for database join are actually pretty interesting, and you can take other entire courses at CMU about that and related topics. But for now, we're just interested in the simple Python set comprehension that does this. So you guys should go ahead and think about that offline. And we'll actually, we're done with this set of lecture notes a little bit early, so what we're going to do is just briefly summarize the set of lecture notes that we're going to go over on Wednesday, and we'll start from there. Oops. All right. So the next set of lecture notes for Wednesday, which is already posted on Piazza, is on data types and functions. And basically, data types and functions, sorry, just scrolling through it, data types and functions are a nice application of all of these set concepts that we've talked about before. So a data type is nothing other than a set, right? So int32 is the set of all 32-bit representations of integers, or char star is the set of all pointers to a variable of type character, right? And so when you declare a variable in C, you'll give its data type, and you'll have, for example, a struct that has an int A and a float B, right? And that's a pair. You can think of the struct as implementing a tuple, or in this case, a pair, where the first element is an int and the second is a float. And that just means that A is an element of the data type int, which is just a set, and B is an element of the data type float, which is also just a set. Right? So again, these mathematical concepts translate fairly directly into code that you can write, and that's why it's useful in a machine learning and programming course to be able to think either in terms of the programming or in terms of the mathematical notation. So structs are ordered pairs. Unions are actually they implement set union, right? So everything that is either an int or a float is in this type union int float, right? So an interesting thought exercise is to think about how and whether this C union type is different from the mathematical expression integers union reals, right? And again, I'll leave that for you guys to think about. And I think actually this time I'm going to pause for maybe just a minute or two to let you guys think about that question, and then I'll give you the answer. All right, so we're back. How is this C union type different from the mathematical expression Z union R? It's actually a little bit subtle, right? So this union type, it's the union of the set of C representations of integers and the set of C representations of floating point numbers. Here, it's the union of integers and floating point numbers, the mathematical objects. And so the difference is just what gets identified with what. So a particular bit string, when you interpret it as a float, is going to give you some floating point number that's different from the integer that you would get if you interpreted the same string of bits as integers. And so here, right, the difference is that some integers and some floating point numbers get mapped to the same bit string. And here, some integers and some floating point numbers also collide, right? 3 is both an integer and a floating point number, but it's a different set, right? So, for example, the C representation of 3 does not turn into the C representation of the real number 3.0. Right? So that's one difference. That's probably the main difference. The other difference, of course, is that there are finitely many integers and finitely many floats in a 32-bit representation or a 64-bit representation, as opposed to the infinitely many that are in this representation. Right? So that's a maybe subtle difference between the code and the math, but it is an interesting one. And it shows you a phenomenon that's actually pretty common. When you take a union, either a union type like this one or a mathematical union, there'll be collisions. There'll be some things that are in both sets, and you'll get only one copy. If you want to be sure you know which set something came from, what you need is something called a tagged union. So C does not have a native concept of tagged union, although you can do it. But a lot of programming languages, their implementation of union types is by default tagged. What a tagged union is a union type where each element is effectively marked with whether it came from the left-hand set or the right-hand set. And so a tagged union lets us always reconstruct, did we put an integer in here or a floating point number? And so here is a mathematical representation of a tagged union, right? So what I've done here, Z cross 1 is ordered pairs where the first element is an integer and the second element is the constant 1. Here, this is ordered pairs where the first element is a real and the second element is a 2, the constant. And then I take the union between this guy and that guy. And so as an exercise, it's interesting to think how you would explain why T1, which is this, is different from T2, which is just Z union R, right? And also to think about how this implements a tagged union, right? And I think what I'm going to do is stop here. I'm going to end the course a little bit early and give you 10 minutes to think about this exercise. And if you have questions about them, about the exercise, post the questions on Piazza, and we'll cover the answer to the exercise at the beginning of Wednesday's class. So I should say as well, my office hours are typically right after class, every Monday and Wednesday. That's in Piazza if you forget. But today I'm not going to hold office hours, both because it's the first class and also because I need to go help another professor set up streaming for their course. And so no office hours today. Please post questions on Piazza if you have them, and please visit my office hours on Wednesday, and of course the office hours of our wonderful TAs who have posted their office hours on Piazza as well. So thanks again for participating, and I'm looking forward to this semester, and I will see you guys on Wednesday. Talk to you later.